solving quadratic equations using the factoring method. And in this video, I'm just going to be doing a whole bunch of examples utilizing that method, the factoring method. In video 1, I showed one example, x squared plus 3x is equal to 18. And I showed you how to solve this one using the factoring method. We got the answers of x equals -6 and 3, and then we double checked them as well. So let's see another example of this here. 32 equals to 2x squared. I suggest that you pause the video, work it on your own. If you need some help, remember the steps are up here in the right hand corner. If you want to double check to make sure that you got the right answer, I have listed the answer to this example and all examples right here. Okay, to solve this one, our first step is to set one side of the equation equal to 0. In this example, it's going to be best for me to move my 32x to the right. And the reason of that is because my leading term, the one with the highest degree, which is 2x squared, I want him positive. That's going to make your next step of factoring much easier. So to move that 32x to the right, I subtract a 32x from both sides. That leaves me with 0 is equal to 2x squared minus 32x. And make sure you put that in descending order on the right. Alright, now I have finished step number 1, which means I move on to step number 2, which says to factor completely. If I follow my factoring checklist, that means I need to find a common factor first if I can. And I do have a common factor here. I have a common factor of 2x. So if I take a 2x out, that leaves me with x minus 16. Now don't forget your equal 0 because we are trying to solve here. I cannot factor any farther, so I have finished step number 2. Step number 3, since it is in the form of something times something equal to 0, then you can solve it by splitting those factors up. On my left, I have 0 is equal to 2x, or on my right, I have the equation 0 is equal to x minus 16. So I have finished step number 3. Step number 4, I'm down to linear equations, so I solve these by isolating the variable. I'm going to start with my right hand one here. To get rid of that -16, I'm just going to add 16 to both sides. That gives me the answer of 16 is equal to x. On the left, to isolate that x, I divide by 2. Which cancels that 2 out on the right, and that leaves me with x is equal to 0 divided by any number is equal to 0. So I have my two solutions here. Now again, pay attention to how the homework asks you for the answers. If it asks for the solution set, meaning the set of answers, it wants the answers in the braces. If it asks for what your variable is equivalent to, so in this example, it would ask what x is equal to. Then you do not need the braces, you just list the numbers. And in both versions, you're just going to separate the solutions with commas in between. So one of these two ways is going to be your final answer. Okay, so I've finished step number 4. Now let me check it. First, I want to check to make sure I have the correct number of solutions. If I look at my degree of this problem, my degree is 2. And I have 2 solutions. So that at least matches what I need. Now let me fully check to make sure that each of these works. So let me first check the x equals 0 solution. So that means I need to take 0 and plug it back in to my original equation up here, any place that I see an x. So I have 32 times x, which I'm going to substitute in 0. And we want to know, is this equal to 2 times my x squared, where again I substitute in 0 for x. On the left, 32 times 0 gives me 0. On the right, 0 squared gives me 0. And when I multiply that by 2, it of course also gives me 0 as well. So that half of the equation checks out. Now I must check the other half, where x is equal to 16. So I go back to my same equation and I plug in 16 for all of the x's. I have 32 times, substituting in 16, and we want to know if that is equivalent to 2 times 16 squared. On the left, I have 32 times 16, which gives me 512. On the right, I'm going to do 16 squared, which is 16 times 16, which gives me 256. And if I multiply that by 2, it should also give me 512. So let me multiply that by 2 as well. It does give me 512. So both of those sides of that equation is equivalent to 512. So 16 checks as a solution there. So I have finished example number 2. Example 3. H cubed minus 25h plus 100 is equal to 4h squared. My first step is to set everything equal to 0. And the best way to go about this one is to move this 4h squared to the left, because I want my leading term, the one with the highest degree, which is this h cubed, I want it positive. It makes your factoring step much easier. So I'm going to move that 4h squared to the left by subtracting 4h squared from both sides. Mix through the left is at descending order, which is h cubed minus 4h squared minus 25h plus 100. And we want to set that equal to 0. Now we have finished step number 1, but I want to comment that this one is not really standard form. And the reason for that is because standard form is only pertaining to quadratic equations. And this is a degree 3 or a cubic equation. Next, I need to factor completely. Well, following my factoring checklist, I have 4 terms, but no common factors, so I move on to my factor by grouping, where you group your first 2 terms together and your last 2 terms together. In my first 2 terms, I pull out a common factor of h squared. When I do that, I am left with h minus 4. Remember, whatever your sign is here needs to carry down there. In my last 2 terms, I have a common factor of 25. So since I have this negative in the middle, I need to think about factoring out a negative from those 2 pieces on the right. Well, if I had a negative 25h divided by a negative 25, that leaves me with just a positive h. And if I have a positive 100 divided by a negative 25, that leaves me with a minus 4. So that negative in the middle changes the signs of the last set of parentheses. Now for factor by grouping to work, you want those set of parentheses to match. And they do. So that now becomes your common factor of taking out an h minus 4. And you're left with h squared minus 25. Don't forget your equal 0 over here. That's the difference between solving and just factoring. Now I've finished my factor by grouping step, but I have not finished factoring completely, because if I look at this h squared minus 25, that is actually a difference of squares. It is a square minus a square. So I can actually factor that one farther. So let me set up the set of parentheses for that. I have h times h to give me h squared. I have 5 times 5 to give me 25. And a difference of squares factors into conjugates, meaning one of them addition and one of them is subtraction. Now don't forget to copy down the rest of your problem. H minus 4 in the beginning and the equal 0 at the end. Now you have factored completely. Alright, now you have things that are multiplied. This is multiplication and this is multiplication. And then it's set equal to 0. So Now we can set each of our factors individually equal to 0. On the left, I have h minus 4 equals 0. In the middle, I have h plus 5 is equal to 0. In the last, I have h minus 5 is equal to 0. So I've finished step number 3. Now I'm going to solve my remaining equations in step number 4. I do this by isolating my variable by performing opposite operations. So on my left, I add 4 on both sides to cancel those out. That leaves me with h is equal to positive 4. In the middle, I subtract 5 from both sides. That leaves me with h is equal to negative 5. And on the right, you add 5 to both sides, leaving you with h is equal to positive 5. So we have these 3 solutions here. Again, pay attention to how the homework asks for it. If it wants the solution set, then you need to put it in the set of 4, negative 5, positive 5, or in any order. If it asks for what the variable is equivalent to, then you have h is equal to, and you input those numbers, but you do not need the braces. Just 4, negative 5, positive 5. So one of these here will be your final answer. So, to check, let me first check to make sure that I have the correct number of answers. If I look back to my problem, I have a degree 3 equation, so it makes sense that I have 3 answers here. Now I need to fully check this problem, which means I need to plug in back of these solutions one at a time to make sure that my equation works out the way that we want. Now I'm going to leave that up to you to do on your own, but these all do check out correctly. That's where I'm going to stop this video. So in this video I did 2 examples of factoring method, and in the next video I'm going to do 2 more examples of solving by the factoring method.